Hi, good afternoon, good evening. My name is John. I live in the city of Ventura. It's for some of my students that are having a little bit of issues with slopes of inverse function and how to find them. Given a function, you want to find the inverse function and then try to find the slopes. The tangential slopes, that is, the derivative of inverse functions. So this is a problem that was imposed upon me. F of x is equal to x cubed plus 2x minus 1 at the value of a equals 2, or x value equals 2. Find the f inverse of a, and that's what we're looking for. Okay. Well, first of all, before we do this though, we have to define something. We're going to let g of x be defined as the f inverse function. Armed with this, we have a formula. G prime of x is equal to 1 over f prime of g of x. What you're going to do is try to take the derivative of the inverse functions of these. It'll come out the reciprocal. It's not a hard proof. You should be able to derive maybe this one, but for our purposes, we're not going to be deriving them. Okay, so here's the g inverse function. Memorize it, and it's going to be probably on your test. So we want to first find f prime of x. F prime of x is going to be just taking the derivative of this. It's going to be 3x squared plus 2 using the power rules for all of these. And we want to find f prime, f inverse. What are we trying to find? Oh, f, I don't even know what we're trying to find. On number 71, it says find f inverse prime of a. So we actually had to find the derivative of that. Sorry about that. Before we do that, f inverse of x, f inverse is equal to 2. Since this is our x value right there, x equals 2. The inverse function would be y equals 2. So we were trying to find f inverse of 2. So we plug it in. 2, that's our y value, is equal to x cubed plus 2x minus 1. Subtracting 2 to both sides, x cubed plus 2x minus 3 is equal to 0. I actually looked it up ahead of time. Let me throw my calculator here. I put in the y equals x cubed plus 2x minus 3, and I graphed it out, and it comes out at x equals 1. That's the root. So the 0 comes out to be at x is equal to 1 right there. And so we just plug it into our new function, f prime of x. So g prime of 1 is equal to 1 over f prime of 1, which becomes 1 over 3 times 1 squared is 3 plus 2 is 5, 1/5. That's your final answer. Okay, so let's do a little recap. What I want to do was first find the derivative of this, which is 3x squared plus 2 from the original function at x equals 2, which means that y equals 2. So we set the y value into the original function and then solve for the x value right over here. You're trying to find the zeros, and once you find the zeros, you just plug it into this function right over here, g prime of 1, which is the same thing as f prime of 1. Right over here. Okay, so it's a pretty easy couple of steps. Let's do the next one, which is problem number 73. The function f of x is equal to sine of x. X is between negative pi over 2 to pi over 2. That's the restriction. If it does not have the restriction, it is no longer an inverse function because it no longer passes the horizontal line test. So we have to put a restriction on x this time. And they stated that in the problem at a equals 1/2, I want to find f inverse of a prime. Okay, thought I had all of these problems kind of like confused a little bit. Of course, we try to find f prime of x first. The derivative of the sine of x is going to be the cosine of x. That's from your basic derivative trig functions. And you're going to set this value equal to 1/2. So sine of x x is equal to 1/2. At what angle will it be 1/2? Given this restriction, it's going to be at pi over 6 or at 30 degrees, okay? Since now we're not dealing with degrees, we're going to keep it in radians, which is pi over 6. So, so g prime of x, or g prime of pi over 6, is equal to 1 over the cosine now of pi over 6. That's equal to 1 over cosine of pi over 6 is root 3 over 2, which becomes 2 over root 3 because we multiply by the reciprocal, 2 over root 3. If you want to rationalize the denominator, that becomes 2 radical 3 over 3. That would be your g prime, the derivative at that point, at a equals 1/2. Pretty simple. I haven't checked the back of the book for this one yet, but I'll check it later. If it doesn't work out, I'll have to redo the problem. Next problem. 77, f of x is equal to x cubed. They give you the inverse function. Of course, it's cube root. Remember, what I want to say something about this x cubed is the inverse function is the inverse function of adding is subtracting. The inverse function of dividing operation is multiplying. The inverse operation of cubing is cube rooting. So we know that these are inverse functions. Okay, and of course, since these are inverse function, it goes through the line y equals x. It's the not horizontal, excuse me, 45-degree line. So at the x's and the y's, as you notice, are changed too as well. First of all, we want to find the domain of the f function, the f inverse function, the range of the f function, f inverse function. We want to graph it out, show the slopes are reciprocals. Okay, so it shouldn't be too difficult. On number 7, part A, the domain of that function, if you graph it out, it looks something like this. That's a cubic function. We know that the domain of the f function is an element of all real numbers. In the x direction, it goes all the way. The range of the f function is also in the y direction, all real numbers. Or if you want to put interval notation, it's going to be negative infinity to positive infinity. Ditto here as well. We want to find the domain of the inverse function and the range. So if we draw a line like this, the 45-degree line actually turns out to be this way. So the domain of the f inverse function is also element of the real number line set, and the range is also of f inverse of x is also the real number line set because it can go up and down in the y direction forever and ever. Okay, part C, we graphed it. We should see that if we draw a 45-degree line right here, I'm going to use a different marker. It should turn out to be a reflection about the line y equals x. And it does look like the reflection. Okay, so we know that these are inverse functions because they're inverse operations. Show the slopes are reciprocal, so we have to find the slope at x equals 1/2 and y equals 1/8. So f prime of x, given that, is 3x squared. F prime, the derivative of that, at that point 1/2. Here's your x value. Turns out to be 1/2 squared is going to be 1/4 times 3. It's going to be 3/4. The next problem, f inverse now of x is equal to cube root of x. So we're going to take the derivative of that, f inverse of x, and we're going to take the derivative of that. That becomes 1/3 x to the minus 2/3. We're using the power rule, changing this to an exponential form. That's the same thing as x to the 1/3. If you're not familiar, going from radical to exponential form. So we're using the power rule, bring down the 1/3 and subtract 1, of course. And so we want to find f inverse of at the point 1/8 this time. And so that's going to be 1/3 times x to the minus 2/3 is going to be, that's going to be in the denominator. So where's my 1/8? And then cube that, cube root that, and then square it. Cube root of 1/8 is 1/2, square root that is 1/4. It's going to be 1/3 times 1/4. It's going to be 1/3/4, and the reciprocal of that is going to be 4/3. So we did notice that the 3/4 and the 4/3, they are reciprocals of each other, and that's what part D says. So show that the slopes, the tangential slopes that is, are reciprocals, and we just showed that. Next problem, 79. Here's your function. F of x is equal to x square root of x minus 4. F inverse function is equal to x squared plus 4. At the point x equals 5, 5 minus 4 is 1, so, and the square root of that is still 1. If I plug in 1 in here, 1 squared is 1, plus 4 is 5. Obviously, 1 comma 5 is a solution to this inverse function. First, we're going to find the domain, the ranges, graph it, and show that the slopes are reciprocals. Let me see one more. Do you have any other problems? Oh, that was easy. Okay. So, part A, let's see what this graph looks like, the function. The parent function is the square root of x function. Y equals square root of x. We put a little bit of a restriction on this one. It looks something like this. That's the square root function. If it's minus 4, on the inside, it has to move to the right 4 units. Excuse me. Here's the right 4 units, and it's going to go this way. So that's what this function looks like without even graphing it on the graphing calculator. There has to be a restriction on the parabolic function here, the squared that makes it a parabola. And I forgot to write it down. X must be greater than or equal to 0, or else it's not a one-to-one function, of course. We're going to graph this one, the inverse function too as well, but later, that's part C. The domain on this is going to be what values of x makes it greater than or equal to 0 on the inside, because if you have a square root of a negative number, obviously, you cannot have an what do you call it, imaginary number on the inside the radical, basically, or imaginary number or square root of a negative number. So we set x minus 4 greater than or equal to 0. Notice that the inside right there has to be greater than or equal to 0, or else it'll be an imaginary number. The square root of a negative number, this means it's positive or 0. Solving this out, the domain for the function f is x is greater than or equal to 4. And what's the range of values for the function? F inverse, no, I'm sorry. For the function, y is going to be greater than or equal to 0 as well, because you cannot have anything negative on the outside here, unless there's a negative in front. For the range, for the domain of the f inverse function,